One of the common issues with Indians is blown head gaskets. So I want to go over in this session on head gaskets, surface finishes, flatness, and types of gaskets. One of the first things you need to do is make sure that the surface here, the cylinder surface, is flat. Quite often they actually get a low spot over here, and it actually starts out narrow and gets wider and wider and wider. It's actually quite a common area through there, but that's not really where they normally blow. Where they blow is across here, this bolt and that bolt there. Front and rear cylinders, they're both under the frame, and they're the hardest ones to get at. So if we're going to look at the head itself, it's actually going to be this one and this one. It's really important to get those ones. They're the toughest ones to get to on the bike, and it's the one that's the most people tend to neglect, and therefore they're the most particular ones to most likely area to blow. The reason why this area here is a weak area is if we actually turn around cylinder, we can actually see that this is the valve port area. So actually on our reproduction cylinders, we've actually added more material through here to give it more support. But you can actually see this thickness through here is where the least amount of material is, so that's where it develops a little bit of a low spot. But it actually starts narrowly in here and then just progressively gets wider through there. So the finish on, you want a very, very fine finish on the cylinder surface itself. In the old days it was real coarse because they had different types of gaskets, like asbestos, and it needed some, the theory was that it actually gripped more. But that's not, today all the gaskets are way better, so we need a fine finish on it. If I actually go over here, here's an original cylinder. Hopefully you can pick up the real coarse machining marks. So with today's gaskets, that's not good. Here's one here that an original one. It's actually somebody's used a copper head gasket that's got embossing in it, but we'll get into that in a little bit. So there's different types of gaskets. There's composite gaskets, like so. There's also a James Teflon blue composite, and there's solid copper, which our solid copper ones are made by James. These are actually not made of roofing copper. A lot of competitors make it out of roofing copper. It's cheaper. It's just wham bam, thank you ma'am. It's not a precision held thickness gasket. So this does cost more, but it's very, very precision. That's what we need for engines. We're not building roofs, we're building precision engines. Solid copper is not going to blow. You can actually, it's actually the answer to most of the head gasket problems. So these two gaskets here, or two bolts, are the most important, because that's where it's actually the most likely to blow. Which on the head are these two here. And actually this is a good example. We can actually see where that one has been leaking. Now here's your solid copper gasket. There are some solid copper ones also on the market that are embossed, meaning they've got a raised portion, a rib going around here. Those are not good news. This cylinder here is actually being fitted with one. They don't really do a great job of sealing. The other thing is the ribbing, it's crushed down, is actually leaving marks into the cylinder, and it'll actually leave the marks into the soft aluminum heads. So that's actually a real bad way to go. So there's different gaskets people sell. What we do is we're on the front lines. This is what we do. This is my trade, is engine building. I'm always on the front lines of this stuff. We see motors coming in here with failures. So we're always constantly looking at ways of improving things, what's on the market, what's failing. So these here are a real good way to go. Solid copper, what you do is you spray on high heat copper coat. Spray both surfaces to it. Make sure the cylinder surface is flat. Make sure your head is flat. Make sure these bolt holes are threaded down to a minimum of 3/4 of an inch. Quite often they are not. So clean these out. If you're going to use any oil on them, on installation, start the oil about 2 or 3 threads down the hole. Because we don't want it on top, because then it's going to migrate around the top and then the sealant's not going to do any good. So don't put it on the bolt itself, but put it just a couple of threads down. Just give a little squirt of oil down there. And then you can bolt your heads on, and your torque is going to be 55 foot-pounds. The solid copper James head gaskets are about 45 to 50 thousandths thick. They're actually precision finished. They're water jet cut for a nice finish, distortion free. A cheaper way to do it is laser cutting. It is cheaper, but water jetting is going to give you a real nice finish all the way around. It's all precision. Whenever you're working on your top end, keep all your stuff organized. It's easier to keep track of things, like so. This is our performance valve spring. It's actually to take up higher lift, better sealing on it as well. But just keep everything in order. Using a good quality assembly lube. So there you have it. Just use good quality products. Indian top ends have got some issues, but this is stuff that we've worked with over the years to perfect it, to make it better, to make it actually not give you any problems, because head gaskets, blown head gaskets is a issue on Indians. So with using the solid copper, apply some spray on copper coat. It's going to really minimize your problems. The thickness of the head gasket is about 45 to 50 thousandths thickness, which original composite ones are about a 1/16 of an inch, which is about 0.62, 0.65 thick. But by the time it actually compresses down, it's about 0.45, 0.50 anyway. So I've pulled original engines apart that are not new old stock, but done some service with original factory gaskets and mic'd them. So they end up between 0.45 and 0.50 anyway. So with the solid copper, you don't get the crush. It allows some compliability. You're not going to have any problems. Solid copper head gaskets can be reused. What you do is you heat it up to a cherry red. Actually hang it on a piece of wire, heat it up to cherry red, and dunk it in some cold water and then stir it around. That anneals copper, brings it back to a nice soft state. And what you can do then is just go over it with some Scotch-Brite, because it's going to have a light oxidized little scale to it. Just take it off with some Scotch-Brite and then refit them to your bike. So they're not a one-shot deal. You can actually keep reusing them several times. When it comes to retorquing them, they're going to take minimum torque. Like composite head gaskets are going to take quite a few retorques. Solid copper, just generally, you tighten it down once, and then you might have to come back a little bit later after 50, 100 miles. Just try it. Just periodically check it, but it actually moves virtually nothing. So that's another nice thing about solid copper, is you're not really constantly retorquing them. They hold their torque real well.